Okay, these have with different tables. I'm telling you all of these tables are exponential relationships. So that means we're going to follow that initial value times our kind of that whatever we're changing by to the power of x. So if I'm looking at a generic y equals a times b to the power of x, a is initial value, and b we would call our growth factor or our decay factor. It's how much we are growing bigger by or getting smaller by. So if I look in my first one, if you can't immediately tell, how do I get from -1 to -2? We have exponential. That means we are always going to be multiplying. So I need to think, what do I multiply -1 by to get -2? If you don't know what it is, you take that second number divided by the first number to get 2. And then I can test it. -2 times 2, that equals -4. So here I multiplied by 2. -4 times 2 equals -8. So it's just kind of a quick test. It's asking us to find our initial value. That means when x equals 0. So I need to be able to go backwards. And if I think to go from -16 to -8, what do? I divide by 2. Same to go from -8 to -4. This is where that patterns work really comes in, so that you start seeing these patterns without really going, oh, I'm looking for a pattern. But your brain just kind of starts looking for those patterns right away. So in this case, I'm going to do -1 divided by 2, which would be -1/2 or -0.5. So -0.5 goes here. And the factor, and it's not saying growth or decay just because we don't know what it is, or we're not trying to give you hints. This one here would be a 2 because it's doubling every single time. And that's what we've actually done that off to the side. And our equation, y equals our initial value times 2 to the power of x. We want to make sure that we're not doing a times as an x sign in between in here. Otherwise, that's going to get very confusing with our variable of x. Looking at our second one, same thing. So it'd be best if you could pause, and then I'm going to go through it and see if it matches up. It's not obvious what I'm multiplying by, at least not to me, so I'm going to do 10 divided by 4. And when I plug that into a calculator, it gives me 2.5. When I test 10 times 2.5, it equals 25. I usually like to just test them all. Sometimes when we have decimals, that last decimal could be rounded, so as long as it's really close, you know it's good. I know these happen to work out each time. And so that's actually my factor is 2.5. I really need that first before I can get that initial factor at some point. So now if I can't figure out what it is, I'm going to take my 4 and I'm going to divide it by that growth factor of 2.5. And I'll end up with 1.6. Just needed to check. And then that is my initial value. Once I have my initial value and the factor, I can write my equation. So y equals 1.6. That's my, think about it, that's your y-intercept. It's kind of that starting value. In parentheses, 2.5 to the power of x outside of the parentheses. We're using the parentheses as a way to do multiplication. And we're putting our x on the outside because at some point we start putting in different pieces in here where we're adding or we're subtracting. Not so much this year, but it's a good habit to get into. Our last table, same thing. You should try it on your own and then just do a quick double check. If you said you wanted to divide by 3, we can't divide by 3 in our equation. Our equation always has multiplication. So you can think about what's the opposite of dividing by 3, and if you get multiplying by 1/3, that's awesome. If you didn't see it, we can calculate it. 27 divided by 81. When you plug that into the calculator, you're going to get a whole bunch of repeating decimals, and that would be 0.3 repeating. It's important that we have that repeating, or it's the same as 1/3. And when I put it into the equation, I'm actually going to use it as a 1/3 so I don't have to write out all those repeating decimals. And if I keep testing it out, it definitely works. And on the decimals calculator, it's not a problem to keep multiplying that in. So that means when I go backwards, I'm going to take 81 divided by 1/3, which would be the same as 81 times 3. And when I plug that in, I get 243. And that would be my initial value. So again, once I have those pieces, I can write my equation. Y equals 243 times 1/3 to the power of x. The next one is just looking at the two graphs and seeing if we can find those growth factors. We have different points listed on this graph here, so it's a little bit easier to find those points. These ended up being on nicer numbers. You should be able to calculate those, and then you're just going to go ahead and see if you can fill in the rest of this. Check with the answer key.